Discuss this peer graded assignment for the course Human Factors in AI um, from Duke University through Coursera. So, in this, we're going to discuss the ethical and privacy implications of user experience in machine learning for standardizing automotive parts catalogs. So, task analysis, the problem here is that standardizing and categorizing automotive parts catalogs from various manufacturers, what happens is that they have their own naming conventions, there's missing data, there's unreliable information, so there's a lot of inconsistency with different data sources, especially different manufacturers. And we want to bring that all together to create one large catalog. So, task analysis, the problem is standardizing and categorizing parts in automotive catalogs from different manufacturers like Nissan, Honda, and Toyota, where data is often inconsistent or missing. Key tasks: automating the standardization of categorizations of millions of SKUs, addressing missing data, and correcting errors across different manufacturer naming conventions. Insights: machine learning can streamline the data cleansing process, significantly reducing manual intervention while improving accuracy and speed. Simplifying the task flow means automating repetitive tasks and allowing users to focus on verifying edge cases. So, user experience design. We have user inputs. Users upload raw parts catalogs in forms like CSVs, Excel, sometimes data transfers. The system then processes the data, identifies inconsistencies, and provides a standardized output. We want feedback loops so users can flag incorrect categorization or missing data. This feedback is used to retrain the model, enhancing its future performance. Transparency: we want to provide detailed reports showing how the model made decisions, including any assumptions or confidence scores associated with corrections. Communicating uncertainty: display a confidence score for every data point the model corrects or standardizes, allowing users to review lower confidence decisions manually. So a couple of privacy considerations that we have here is the privacy concerns is, since the system handles proprietary catalog data, protecting that sensitive information such as pricing or part sourcing is critical. So we want to make sure that we can mask a lot of our sources, especially if it should not be given out to just the public, right? Applicable privacy laws, depending on the location of data processing or user interaction. Laws like GDPR, if the data involves European users, or CCPA for California users, may apply. Implementation, encryption, access controls, and anonymization is used where appropriate. Ethical considerations. We could have sources of bias. The model may exhibit bias if one manufacturer's data dominates the training set, resulting in overfitting to specific naming conventions. Additionally, gaps in the data may lead to skewed results. Fairness: we have to ensure balanced representation across manufacturers during training, so no single data set influences the model disproportionately. Accountability: we have to incorporate regular audits of the system's outputs and maintain human oversight in the correction process. And transparency: provide clear documentation of the model's decision-making process and retaining procedures. Allow users to trace back every correction or categorization. Here is a flowchart of what this could look like. So we have basically user input. They provide the parts catalog. We data ingest the raw data. Then it goes into pre-processing, where we kind of clean it and standardize the data to make sure that it is consumable for all. Then it goes through feature engineering. Once feature engineering puts our eyes on it, does some clean work, then we ask ourselves, is the data clean and standardized? If it's no, then it goes back to feature engineering. If it's yes, then it proceeds to the predictive modeling. Here we can apply ML models to predict missing attributes, categorize parts, and we can output standardized parts. and then we can apply confidence scores to that. We can then process the data and then do some model evaluation. After all of this is done, we can create the standardized parts catalog. We can create a unified parts catalog with standardized attributes and confidence scores. Um, and then we can go into using letting users access this catalog to manage inventory. With inventory management, users can access the catalog to manage their inventory, and they can provide inventory insights and recommendations off of this data. And then it goes to part sales and recommendations, where users can search for parts using the standardized catalogs. We can facilitate part sales, providing accurate information and pricing. And then we want to keep going through a feedback loop where we get feedback from our users to incorporate feedback mechanisms to continuously improve the system's accuracy and the user experience. We also want to get how this is working for our users, so we'll keep model retraining and improving the model. With all of this, we want to ensure that data security and privacy measures protect sensitive information, as well as just making sure that we are doing our due diligence to make sure that we are providing the best service that we can.